Hello everyone, in this video we are just going to interface common cathode type 7 segment display with our Renesas RL78 F14 series microcontroller. Let's get started. So now let us try to understand the schematic that we are going to build for interfacing this common cathode type 7 segment display with our microcontroller series RL78 bar F14. So you can see this is the development board that we are going to use, and this is the 7 segment display that we are going to connect to our development board. And in this development board, this is the actual rail. You can see the box highlighted in blue color is the one which we are going to utilize for connecting the 7 segment display. So what I will do is I will connect the A terminal of the 7 segment display to P63 of the microcontroller. B terminal will be connected to P65 pin of the microcontroller. C terminal will be connected to P67 of the microcontroller, and D terminal will be connected to P155 of the microcontroller. E terminal will be connected to P156 of the microcontroller. F terminal will be connected to P140 of the microcontroller. G terminal of the 7 segment will be connected to P77 pin of the microcontroller, and finally the H terminal of the 7 segment will be connected to P75 pin of the microcontroller. And the ground pin of the 7 segment, I will be connecting it to the ground of the development board, that is the ground of the microcontroller, that is pin number 43 in this rail. A terminal of the 7 segment to P63, B to P65, C to P67, D to P155, E to P77, H to P75, and finally ground of the 7 segment I will be connecting it to the pin number 43 of this connector. So these are the pins that I am going to utilize for interfacing 7 segment display to our microcontroller. So coming to the actual development board, you can see here is the CN1 connector, and here is the pin number 1 of this CN1 connector. You can clearly see this is the pin number 1 of the CN1 connector. So as I said, I am just going to utilize these pins in an order from pin number 20, 27, 28, 29, 30, 27, 29, 31, 33, 35, 37, 39, 41 for connecting A, B, C, D, E, F, G, H of the 7 segment display, and finally I am just going to connect ground of the 7 segment display to the ground of this connector, which is in the connector terminal number 43. So regarding the pin details of the 7 segment display, we have already discussed in detail about the pinout diagram of 7 segment display, both common anode type 7 segment display and common cathode type 7 segment display, in a separate video. I hope you watched this video before this particular video in this playlist, so I hope you remember that. And the center terminal in the top and bottom of the 7 segment is common ground. So since this is a common cathode, we just want to provide ground to any one of the center terminal of the 7 segment display. You can utilize any one of G1 and G2 for providing ground. Both are internally sorted. So as I mentioned here, mentioned before in the connector schematic, A terminal of the 7 segment will be connected to P63. So P63, this particular pin right over here is the P63, which is the connector number 27 in the CN1. B terminal will be connected to P65 of the microcontroller, which is available in the CN1 connector pin number 29, and C terminal will be connected to P67, which is also available in CN1 connector pin number 31. 7 segment will be also connected to the same to the pin number P155, which is also available in the CN1 connector pin number 33, and E terminal will be connected to connector pin number 35 controller, which is available in the CN1 connector pin number 37, and finally the in connector 1 CN1 pin number 43 we are having a ground pin right over here. So this ground pin will be connected to the center terminal of the 7-segment display for grounding that. And regarding the schematic diagram of this development board, I have already provided a document for this particular development one by one what I am doing in this video. So let's start the configuration segment of the video. So now let us try to open the CubeSuite Plus for CCRL IDE for creating our project for the microcontroller. You can see in this IDE opened, I'm just going to create my new project. Just click on the project tab in the top of the window and then hover over this create new project and click on it for creating your new project. And in the window that is popping out, just type in the microcontroller name. In my case, I'm just typing R5F10PPJ, and you can see the highlighted microcontroller will be selected by default. So just cross verify that the pin number is correct for your microcontroller. In my case, it is 100 pin, it is correct. So I'm just leaving it. Or if it is anything different like this one or this one, just click and select anything as per your requirement. Just left click and select it as per your requirement. And once after selecting the microcontroller, just provide a name for your project in this project name tab. I'm just providing it to be Pro. And in place of this place tab, just click on this browse button for selecting the repository or directory in your local folders where you want the project to be stored. So let me just make a folder right over here, RL78. And I'm selecting that folder and I'm clicking on the create button for creating my project for this particular microcontroller selected. You can see on the left of the IDE we are having a particular tab called project tree. So this particular tab will be containing several segments of the microcontroller. Those are very important. First and foremost segment is the pin configurator segment, and next segment is the code generator segment, and the next segment is the file segment. So these three are the major segments that is generated for your microcontroller. So this pin configurator segment is useful for visualizing the configurations that has been done for your particular microcontroller. So when I double click on this device top view, you can clearly see this is the layout diagram of my microcontroller RL78 bar F14, that is R5F10PPJ. You can see each pin description has been provided right over here. Once the configurations is done, you can see the configurations that has been done as a whole in this layout. So for that purpose, this pin configurator has been provided. So using this code generator segment right over here, you will be able to generate your own base peripheral software that is required for your microcontroller as per your user application. So I will be showing you how to configure your microcontroller in a while as per your application needs. But before that, we just want to do some basic configurations that needs to be done for almost all the programs. Just double click on this clock generator tab inside the code generator and you can see these configurations, that is the default configurations that needs to be fixed in the microcontroller before moving on. So let's take an example. This particular PIOR00 is yet to be assigned to the function PI00 and the respective port pin for that function is P17 by default. So if you need any alternate port pin to be configured for this function, let's check it out. Just click on this drop down. You can see the alternate pin that can be assigned with the same function is P66. So if you want that particular pin to have this feature, you just want to select that. So most often we will not be changing anything right over here. We can use all these functions for all these pins as it is. So if in case anything is required, I will just intimate you in future lecture videos. But for now, we will be fixing these settings by default. Just click on fix settings for fixing these settings as default settings in this microcontroller. Once that is done, just click on chip debug settings tab right over here. And this is a tab which is useful for enabling the debug option in your microcontroller. So if this is disabled, you will not be able to program your microcontroller using debugger, or you will not be able to debug your microcontroller using debuggers like E1, E2, E2 Lite, etc. So for that, just click on used radio button right over here. In my case, I'm just going to select the E1 right over here. If you are using any other emulators like E2 or E2 Lite, you just want to select the respective radio buttons right over here. So in my case, I'm just leaving this to be E1 selected. That's all about the basic configurations that you want to do. In addition to that, just double click on this watchdog timer right over here in the project tree inside the code generator, and you can see by default this watchdog timer is enabled or it is used by the code generator. So you just want to disable it. So I will teach you what is this watchdog and how to configure this watchdog in this microcontroller in a separate video. And for now, for almost all the videos, I will be disabling this watchdog, and in a separate video we will learn how to enable the watchdog and how to utilize its features for safeguarding our microcontroller. That's it. These are all the required basic configurations that you want to do for almost all the programs. So now let's just move for configuring our microcontroller as per our application needs. So as per the schematic discussion that we have done in the initial segment of this video, we just very well know these are the pins to which the 7-segment display terminals are connected to the microcontroller. That is, for example, A terminal is connected to P63, B terminal is connected to P65, etc., and it goes on like this. So now we are just going to configure all these pins as output pins. As we know, 7-segment display is a output device and it is nothing but an LED connected to 8 terminals of microcontroller. We just want to configure the corresponding pins to which the 7-segment terminals is connected to the microcontroller as output pin, and you can manipulate the data available in the 7-segment with the help of the configured output pin. So let me just configure all these pins as output pins. So for that, double click on this port right over here and move to the port 6. So in this particular naming, you can clearly see the last number right over here represents the pin number, and other than that, the prefix numbers along with the alphabet represents the port number. That is, in this particular example, P63, the 3 represents the pin number and the P6 represents the port number. And in this example, the 5 represents the pin number and P6 represents the port number. And in this example, 5 represents the pin number and P15 represents the port number. So I just want to make port 6 pin 3, port 6 pin 5, port 6 pin 7 as output. So port 6, moving to the port 6, I'm just going to make port 6 pin 3, 5 and 7 as output. And moving to the port 7, I just want to make 5 and 7 as output. Moving to the port 7, I'm just going to make 5 and 7 as output. And moving to the port 15, I just want to make pin number 5 and 6 as output. Moving to the port 15, 5 and 6, I'm just making it as output. You just want to select the radio button, that's it. If you want to configure this pin as input, you just want to select this. If you want to configure it as output, you just want to select this. If you don't want this configuration, you just want to select unused. That's it. That's all about the configurations that you want to do. And moving to the port 15, port 14, I just want to make pin number 0 as output. Pin number 0, I'm just making it as output. Now, the configuration required for interfacing 7-segment display with our microcontroller is complete. We have configured all these pins as output pins. Now I'm just going to generate the basic drivers required for interfacing 7-segment displays. Just click on the generate code right over here for generating the base drivers required for writing your application program. You can see the code has been generated. There is a file created called code generator. Just click on the plus near it. You can see the main.c file. So this is the generated code. The base code has been generated with all the configurations that you have done. That is, all the output configurations that you have done, the base code has been generated. So now you can use the corresponding pins that you have configured right over here as output pins, and you can build your own application program as per your need. Now I'm just going to write down a function which is useful for splitting a byte of data into 8 individual bits, and based on each individual bit status, whether it is 1 or 0, it will turn on the pin representing that particular bit. So let me just explain while I am writing down the function. So let's take the function name to be print data, and this function receives one parameter. Let's take the parameter name to be data of unsigned char type. So this print data function receives one parameter of unsigned char type, and let us assume that the data that is passed to this function is 0x3c. So 0x3c is nothing but 00111100. So this is the 8-bit binary representation of 0x3c. So just assume that this is the data that has been passed to this function by calling this function in this manner. That is like this: print data of 0x3c. So with this example, let us try to understand how each of the steps that is written inside this function works. So as the first step, we are just going to check for the condition of 0th bit 0. That is, we are just going to decide the state of the pin which is connected to A terminal of the 7-segment display. So A. So data ampersand of 0x01. If it is 0x01, that is the result of this operation, data ampersand of 0x01, if I am getting the result of this operation to be 0x01, I will be turning on the pin representing bit 0. Else, if it is not 0x01, that is, if the result of this operation data ampersand of 0x01 is not 0x01, I will turn off the pin representing bit 0. That's it. So this particular if-else conditional statement is useful for deciding the state of the pin which is representing bit number 0, or for deciding the state of the pin which is connected to the A terminal of the 7-segment display. So let us try to understand this deeply. So 0x01 is nothing but 00000001. So when you perform AND operation between these two, what I will get is, you can clearly see, anything AND of 0, I will get 0 as the result. So 0 ampersand of 0, I will get 0. 0 ampersand of 0, I will get 0. 1 ampersand of 0, also I will get 0. As we know very well, 0 0 is 0 in AND, 0 1 is 0 in AND, and 1 0 is also 0 in AND, and the only possibility for making the result to be 1 in AND is 1 1. So 1 ampersand of 0 is also 0. Again 1 ampersand of 0 is also 0, and 1 ampersand of 0 is again 0, and 0 ampersand of 0 is again 0, and finally 0 ampersand of 1 is 0. So I'm getting 0x00 as the result of this AND operation of 0x3c ampersand of 0x01. So this else part will be executed, turning off the bit number 0 in my example. And for deciding a state of bit number 1 or the pin representing the bit number 1 in the byte of data of this parameter, the condition goes like this: data ampersand of 0x02 is equal to 0x02. I will be turning on the pin representing bit number 1 and I will be turning off the pin representing bit number 1 if this condition fails. So let's take the same example. 0x02 is nothing but 10. So here also you can see 0 ampersand of 1, I will get 0. So this else part will be executed, which will be turning off the corresponding pin which is representing the bit number 1 in the byte of data. So here the pin to which the 7 segment is connected is B. So I'm moving to the next consequent bit number, that is bit number 2. So for deciding a state of pin that is corresponding to bit number 2 in the byte of data, I just want to perform data ampersand of 0x04 is equal to 0x04. And if this condition is true, I will turn on the pin which is representing bit number 2, or else I will be turning off the pin which is representing bit number 2. So let's take the example for understanding this further. So this is 0x04, and when I perform AND operation between these two, what I will get is, you can clearly see only in this portion 1 ampersand of 1 I will get 1 right over here. Rest all the bits I will be getting 0 because we are having 0 right over here. We very well know 0 and with 1 or 0 we will get only 0 as the result. So here this condition will be true, making the corresponding pin which is representing bit number 2 in the byte of data to be high. Coming to the next bit, that is bit number 3, which is connected to D terminal of the 7 segment display. So for checking for the state of bit number 3 in the byte of data, I can write like data ampersand of 0x04 is equal to 0x04, and I will be turning on the pin representing bit number 3 if this condition is true, and I will be turning off the same pin if this condition is false. So let's try to understand this. This one is 8 and 8. So here 8 means 10. This is the byte of data representing 0x08. When I perform this AND operation between these two bytes, you can clearly see I will get 0x08. As we know, 1 ampersand of 1 I will get 1. Other than this, I will get 0 in every other places. And for bit number 4 of the byte, I can check like 10 is equal to 10, and this will turn on the pin representing bit number 4, and it will turn off the pin representing bit number 4 if this condition is false. And this particular bit is representing the pin which is connected to E terminal of the 7 segment display. So when I try like this is 10, so 1 ampersand of 1 I will get 1 in this place and 0 everywhere in the byte of data. So this condition will be true, making the bit number 4 in the byte of data to be high. So this condition will be satisfied. Now I am writing down the condition for bit number 5, which is connected to the F terminal of 7-segment display. So I can write like data ampersand of 0x20 is equal to 0x20. I will turn on the pin which is corresponding to bit number 5 in the byte of data, and if this condition is false, I will turn off the pin which is corresponding or representing to bit number 5 in the byte of data. So 20 is nothing but 10. So 1 ampersand of 1 is 1, and in every other bit positions I will be having 0 as the value of the result of AND operation right over here. And moving to the bit number 6 and 7, I'm just going to write down two different conditional statements for bit number 6 and 7. 6 and 7. So this condition right over here, that is the bit number 6 condition, is useful for deciding a state of pin which is representing bit number 6 in the byte of data, or the state of the pin which is connected to G terminal of the 7-segment display. So I can write like 40 is equal to 40, and this particular condition statement, that is bit number 7 condition statement, is useful for deciding the status of pin which is representing bit number 7 in the byte of data passed as parameter to this function, and also this particular condition is useful for deciding the state of output pin which is connected to H terminal of the 7-segment display. So I can write like data ampersand of 0x80 is equal to 0x80. I will be turning on the pin which is representing bit number 7 in the byte of data, or else I will be turning off the same bit number 7 representing pin. So let us just test whether how these two conditions works. So 0x3c ampersand of 0x40. So 0x40 is nothing but this one. So now you can clearly see 0 ampersand of 1, I will be getting 0 as the result, and all the other bits will be 0 because we are having zeros in all the other respective bits. And going to the final condition of the status of bit number 7, the AND operation is between 0x30 and 0x80. So 80 is nothing but 10 00 00 00. So 0 ampersand of 1, I will be getting 0, and rest all the bits as usual we will be getting 0 because we are having 0 right over here in the respective bit positions. So this is how each and every condition works right over here, and it will help us to turn on the particular pin and turn off the particular pin based on the individual bit status that is available in the byte of data that has been passed as parameter to this function. So we have successfully written a function which is useful for dividing a byte of data which has passed as parameter to this function into 8 individual bits, and based on individual bit status starting from bit number 0 to bit number 7, it will be turning on or turning off the corresponding pin which is representing to that particular bit number. In our case, the bit 0 of the byte is representing the pin which is connected to A terminal of the 7-segment display, and bit 1 is representing the pin which is connected to B terminal of 7-segment display, and bit 2 is connected to C terminal of 7-segment display, and bit 3 is connected to D terminal of 7-segment display, and bit 4 is connected to E terminal of 7-segment display, and bit 5 is connected to F terminal of 7-segment display, and bit 6 is connected to G terminal of 7-segment display, and bit 7 is useful for deciding a state of pin which is connected to H terminal of the 7-segment display. So for interfacing devices like 7-segment, LCD, etc. with our microcontroller, we are just going to often use this particular function called port data for passing the data in a parallel manner to the port of 7-segment or LCD in our program. So let me just copy this function and I'm going to paste it right over here. Let's take it to be between the start and end of global variables. So from our previous one of our video of 7-segment display working explained, we just derived several hexadecimal values for printing data to both common cathode type 7-segment display and also common anode type 7-segment display, right? So from that video we just derived these hexa values. I hope you remember this. So this is the hexadecimal value for printing 0 in the common cathode type 7-segment display, and this is the hexadecimal value for printing the number 1 in common cathode type 7-segment display, and this is the hexadecimal value for printing 2 in the 7-segment display, and this is the value for printing 3. This is the value for printing the number 4 in 7-segment display, and this is the value for printing the number 5 in 7-segment display, and this is the value for printing the number 6 in 7-segment display, and this is the value for printing the number 7 in 7-segment display, and this is the value for printing the number 8 in 7-segment display, and this is the value required for printing number 9 in 7-segment display. And all these values are useful for printing the data in common cathode type 7-segment display. So I'm just going to take all these values and put it right over here just before the first line of the while of one logic program. And now coming to the print data function, we are just going to alter this as per our need. So here you can clearly see the bit 0 is representing the pin which is connected to A terminal of the 7-segment display. So in this place I just want to turn on the output pin which is connected to A terminal of the 7-segment display from our microcontroller, and in this place I just want to turn off the same pin which is connected to A terminal of the 7-segment display, which has been configured as output pin. So as we discussed, the A terminal is connected to P63. So I just want to turn on the P63 right over here, and I want to turn off the P63 right over here. So we very well learned the methodologies for turning on a particular bit and turning off a particular bit without disturbing other bits in the register of a microcontroller while we are interfacing LEDs with our microcontroller. I hope you remember that. Now we are just going to use the same methodology for turning on the pin and also for turning off the pin. So P6 is equal to P6 R of 1 left shifted by 3. So this will turn on the pin which is connected to A terminal of the 7-segment display. And for turning off the same pin right over here, I'm just going to write P6 is equal to P6 ampersand of negation of 1 left shifted by 3 times. And similarly, B terminal is connected to P65. So I can write like P6 is equal to P6 R of 1 left shifted by 5. And for turning off the same pin, I can write P6 is equal to P6 ampersand of negation of 1 left shifted by 5. C terminal is connected to P67. So for turning on the P67, Right over here I can write P6 is equal to P6 R of 1 left shifted by 7. And for turning off the same pin, I can write P6 is equal to P6 ampersand of negation of 1 left shifted by 7. And D terminal is connected to P115. E terminal is connected to P11156. D terminal is connected to P155. E terminal is connected to P156. F terminal is connected to P140. G terminal is connected to P77 and H terminal is connected to P75. P77, H terminal is connected to P75. So let me just write down the programming lines required for all these lines for turning on the respective pin and also for turning off the respective pins. 15. So 15, R of 15, 5. Here I am just going to turn on the bit number 6 of P16. And here I am just going to turn off the bit number 5 of port 15. Here I am just going to turn off the P14 0, and here we are just going to turn on the P14 0. Here I am just going to turn on the P77, and here I am just going to turn on the P75. Here I am just going to turn on off the P77, and finally here I am just going to turn off the P75. That's it. So as per your pin configuration that you are doing right over here, you just want to use the respective pin in the conditional statements, right over here. So in my case, I'm connecting the terminal A of the 7 segment to P63. So that is why I have used P63 right over here in this conditional statement. If you are using any other pin for connecting it to A terminal of 7 segment display from your microcontroller, you just want to configure and write to that particular pin in this place. That's it. You can use different pins as per your wish. So now coming to the logical part, now we are just going to build a simple logic for displaying numbers from 0 to 9 in the 7 segment display, and again when the number reaches 9, again it must roll back to 0 and it must display from number 0. So this is what the logic that we are going to build. So for that we got all the hex values required for printing the respective numbers in the common cathode type 7 segment display from the previous video, and also for interfacing a 7 segment display we have write down a function called print data right over here, and we have altered the function as per our program configuration. That is the output pin configuration which has been connected to 7 segment display. So now the work is very simple. We just want to call the print data function, and if I pass the value 3f to this function, this corresponding 3 of data will be split into 8 bits, and as per the bit status of each individual bits available in 0x3f, the corresponding output pins will be turned on or turned off for displaying the corresponding number. So when I write like this print data of 0x3f, this byte of data will be passed as parameter to this function, and this 3f will be split into 8 individual bits, and based on the individual bit status, whether it is 1 or 0, the corresponding output pins representing that particular bit number will be turned on if the bit value is 1, or it will be turned off if the bit value is 0. So based on that particular bit values, the value will be displayed in the 7-segment display. So we derived these values for displaying the numbers from 0 to 9 in the common cathode type 7-segment display. So when I write 0x3f, the number 0 will be displayed in the 7-segment display. So this is the logic. And when I write 0x06, the number 1 will be displayed in the 7-segment display. So let me just provide a delay right over here. So I just want to write down a delay function somewhere else right over here. So let me just write over. So let me just write above this print data function. So this is a very simple loop delay which we used in several previous of our videos. So I'm just going to write simply while of d minus minus. So after printing the number 0, I'm just producing a delay right over here, or I'm just waiting here in the program as it is for a certain period of time. And after the delay, I'm just going to write the data for printing the number 1 on the 7-segment display. So this is the data required for printing the number 1 on the 7-segment display. And this is the after the delay of the number 1, I'm just going to print the data 2 on the 7-segment display by passing the number 0x5b. And after the 2, I'm just going to print 3 on the 7-segment display. And after the 3, I'm just going to print 4 on the 7-segment display. And after 4, I'm just going to print 5 on the 7-segment display. And after 5, I'm just going to print 6 on 7-segment display. After 6, I'm just going to print 7 on 7-segment display by passing 0x07. And after 7, I'm just going to print 8 on 7-segment display by passing 0x7f. And after the 8, I'm just going to print 9 on 7-segment by passing the data 0x6f. And that's it. Since all these lines are written inside the while of 1, that is the main loop of the program, again it will start from this particular line, because this is the first starting line of while of 1. So again the 0 number will be printed after the final line right over here. So numbers from 0 to 9 will be printed on the 7-segment display with a particular delay for each number, and after the final number 9 printed on the 7-segment display, again the number will be rolling back to the number 0 and it will be start incrementing. So this is the logic of the program that we are going to write. Now I'm just going to build this program. Sorry, I just want to rename this function as the same name as the definition done right over here. Now I'm just building this program. You can see the build is successful. Now before downloading the flash to the microcontroller, just make sure that right click on this RL78 debug tool right over here and hover over this using debug tool and select the respective debugger required. In my case I'm using E1, so I have selected E1 right over here, but if you are using any other E2 or E2 Lite, just select it right over here. And after that just click on F6 on the keyboard or this particular icon right over here for downloading the flash to the microcontroller using E1 or E2 emulator. You can see the flash is being downloaded to the microcontroller. So for running the program in the microcontroller, just click on this play button right over here, or F5 in the keyboard for executing the program. So as per the schematic shown right over here on the screen, I have already connected all the terminals of the 7-segment display to the microcontroller output pins required as per the schematic. So as per the schematic shown to you right over here, I have already built the schematic circuit with the help of breadboard and the development board that I am using. So here you can see this is the output that I got in the hardware. The numbers from 0 to 9 are being printed in the 7-segment display as per our logic written in the program. So we successfully interfaced a 7-segment display, that is common cathode type 7-segment display, with our Renesas RL78 microcontroller for printing numbers from 0 to 9. See you in the next video. Thanks for watching.